Hello and welcome to today's presentation. Today we'll be talking about heat and specific heat capacity. In this presentation, you'll be learning about heat as an energy, the specific heat capacity, and the applications of specific heat capacity in our daily life. Now, what is heat? Heat is the energy that is transferred from one body to another as a result of a difference in temperature. If two bodies at different temperature are brought together, heat is transferred. Heat flows from the hotter body to the colder body. The effect of heat on this transfer of energy is usually but not always an increase in the temperature of the colder body and a decrease in temperature of the hotter body. A substance may absorb heat without an increase in temperature by changing from one physical state to another, such as from a solid to liquid, the process is called melting, from solid to vapor, which is sublimation, from a liquid to vapor, which is boiling. The important distinction between heat and temperature, heat being a form of energy and temperature being a measure of amount of energy, was clarified during the 18th and 19th century. Now, what are the ways of heat transfer? Whenever there's a difference in temperature, heat transfer occurs. Heat transfer may happen rapidly, such as through a cooking pan, or slowly, such as through the walls of an insulated cooler. There are three types of heat transfer method: conduction, convection, and radiation. At times, all three may happen simultaneously. Now let's look at this diagram. In a fireplace, heat transfer occurs by all three methods: conduction, convection, and radiation. Radiation is responsible for most of the heat transferred into the room. Heat transfers also occurs through convection into the room, but at a much slower rate. Heat transfer by convection also occurs through the cold air entering the room around the windows and hot air leaving the room by rising up the chimney. Conduction is heat transfer through direct physical contact. Heat transfer between the electrical burner of a stove and the bottom of a fan is transferred by conduction. Sometimes we try to control the conduction of heat to make ourselves more comfortable. Since the rate of heat transfer is different for different materials, we choose fabric such as thick wool sweater that slows down the transfer of heat away from our body in cold weathers. Let me give you another example. As you walk barefoot across the living room carpet, your feet feel relatively comfortable until you step on the kitchen floor. Since the carpet and tile floor are both the same temperature, why does one feel colder than the other? This is explained by the different rate of heat transfer. The tile material of the kitchen floor removes heat from your skin at a greater temperature and a greater rate compared to the carpeting, which makes it feel colder. Some materials simply conduct thermal energy faster than the other. In general, metals such as copper, aluminium, gold, silver are good heat conductors, whereas materials like wood, plastic, and rubber are poor heat conductors. Now let's look at specific heat capacity. What is specific heat capacity? In general, specific heat capacity, simply specific heat, refers to the heat capacity per unit mass of a pure substance. In other words, it is defined as the amount of heat needed to increase the temperature of 1 kg of material by 1 degree and is expressed in terms of J, joule, kilogram per degree Celsius. Specific heat capacity changes with the change in material, type, or phase and can be considered for objects of any arbitrary size. As a life-sustaining factor on Earth, water has one of the largest specific heat capacities among all materials in this table. Specific heat There's two types of specific heat capacity: specific heat at constant volume and specific heat at constant temperature. Specific heat at constant volume is when volume remains constant while heated through a short range of temperature and is denoted by the symbol CV. Specific heat at constant pressure, on the other hand, is when the pressure remains constant while heated through a short range of temperature and is denoted by the symbol Cp. Specific heat at constant pressure is more commonly used and what we'll be looking at today.
Hello everyone. Today I'm going to talk about what is the formula of heat capacity. Did you all know who invented the formula of the specific heat capacity? The Scottish scientist Joseph Black in the 18th century noticed that equal masses of the different substances needed different amount of heat to raise them through the some temperature interval. From this observation, he found the concept of specific heat. The most important thing in the specific heat capacity is the formula, which is delta Q equals to mc delta T. As we discussed above, the specific heat is the relation of temperature change of an object with water. Heat energy equals to mass of the object of substance times with specific heat capacity times with change in temperature. The derivative of the specific heat formula is Q refers to the heat energy in joules, M refers to the mass of the substance in kilojoule. C refers to the specific heat in joules per kilogram. Delta refers to the symbol of change. Delta T refers to the change in temperature in kelvins. Let's see some of the examples to know more about the formula of the specific heat capacity. If the specific heat is gold is 129 joule per kilogram Kelvin, then what quantity of heat energy is required to raise the temperature of 100 gram of gold by 50 Kelvin? First of all, write down the things given in the question. For example, mass of the gold, specific heat temperature. For the calculation, we must put all the value inside the formula and find the Q value. So the energy required to raise the temperature of 100 gram gold is 645 joule. Example 2. Suppose a pot is heated by transferring 1679 kilojoule of heat energy to the water. Moreover, if there is 5000 kilojoule of water in the pot and the temperature is raised by 80 Kelvin, then find the specific heat of water. For the solution, let's write down the things given in the question. Mass equals to 50 kilojoule, temperature equals to 80 Kelvin, specific heat equals to 1676 kilojoule. Now put all the values in the formula. But before that, we have to recognize the formula to find specific heat. Change the previous formula to C equals to Qm delta T to find specific heat of water. Now putting values in the rearranged formula. C equals to 4190 joule per kilogram Kelvin. Hence the specific heat of water is 4190 joule per kilogram Kelvin. Let's see, why does water have a high specific heat? It is because of the hydrogen bonds. Because water is the polar molecule, with a large electronegativity difference between hydrogen and oxygen. Hydrogen bonds from between the positive hydrogen atoms in one molecule and the negative oxygen atom in nearby molecules. It takes a lot of energy to loosen and break the hydrogen bonds between water molecules. This is the reason that ocean cool down slower than the land does. Can specific heat be negative? Not as far as we know on this planet, but possibly in some stars or gas clouds. That's all about formula of the high specific heat capacity and specific heat capacity. Thank you.
Hello, I'm Shishar Madi from C1 and I'm here to talk about the applications of specific heat capacity. Number 1, the cooking pot. Different parts of a cooking pot are made up of different materials. The base of a cooking pot is usually made up of copper because, number 1, copper has low specific heat capacity so that it needs less heat to raise up the temperature. Second, copper is a good heat conductor. And third, copper has a high density. The heavier base can make the pot become more stable. Then, the handles of a cooking pot is usually made up of plastic or wood because plastic and wood have high specific heat capacity. The temperature won't become too high even if it absorbs large amount of heat. Second, plastic and wood are good heat insulator. Plastic and wood have low density, hence they do not add much to the total weight of the pot. Moreover, the body of the cooking pot is usually made up of stainless steel because steel has low specific heat capacity and hence need less heat to raise up the temperature. Also, steel does not react chemically with the food. Next, the car engine. Water is used to cool down the car engine. Water is also used as the cooling agent in the car cooling system because it has high specific heat capacity and it can also absorb a large amount of heat without high increase in temperature. It is also cheap and can be obtained easily from anywhere. Water is pumped through the channels in the engine block to absorb heat. The process is almost like the hot water flows to the radiator and is cooled by the air flows through the fins of the radiator. The cool water flows back to the engine again to capture more heat and the cycle is repeated continuously. Next, we can also talk about the applications of specific heat capacity by relating it with factories with low ceiling. Some factories with large machinery are constructed with low ceilings to reduce the volume of air inside the building. Why, you may ask? The smaller the mass of the air will have smaller heat capacity. As a result, less heat needs to be removed to reduce the temperature of the air. This will then reduce the air conditioning cost for the factory. Next, we can see the thermal radiator. Thermal radiators are always used in cold countries to warm the house. Hot water is made to flow through a radiator. The heat is then given up from the radiator, is then warming the air of the house. The cold water then flows back to the water tank, and this process is repeated continuously. Water is used in the radiator because it has high specific heat capacity. Next, we'll take a look at land and sea breeze. Land breeze has lower heat capacity than seawater. During nighttime, the temperature of the land drops faster than the sea. Hot air, which is low density, above the sea rises. Cooler air from the land blows towards the sea and hence produces land breeze. Meanwhile, on the other hand, sea breeze. Land has lower heat capacity than seawater. Therefore, In daytime, the temperature of the land increases faster than the sea. Hot air, which is lower density, above the land rises. Cooler air from the sea flows towards land and hence produces sea breeze. And lastly, we'll take a look at moderate climate. Places with the presence of lakes, sea, and ocean may have more moderate climate. This is because water has large specific heat capacity. During daytime, when it's hot, water from the lake or sea absorbs heat from the surroundings. This helps to reduce the temperature of the surroundings. Meanwhile, during nighttime, the water releases the heat absorbed during daytime and hence prevents the temperature from dropping too much. As such, places near a larger masses of water will have smaller ranges of temperature and hence a more moderate climate condition. That is all for me, and thank you for watching.